Campbell California-based digital manufacturer VELO3D announced that Boom's Supersonic's XB-1 aircraft includes 21 flight hardware components that were manufactured by VELO3D's Sapphire 3D metal printer. Unveiled at Boom's hangar in Centennial in Colorado, XB-1 marks a turning point in commercial viability for supersonic travel and demonstrates the power of additive manufacturing or 3D printing to enable innovation while accelerating product development. Boom's XB-1 will fly with titanium 3D printed components, most of which perform critical engine operations. All parts are manufactured on VELO3D's Sapphire system. VELO3D's technology allows the production of lightweight, complex designs for mission-critical applications in the toughest operating conditions. Boom Supersonic and VELO3D announced a partnership in 2019 to manufacture complex flight hardware to build XB-1, and ran a series of qualification trials on VELO3D's Sapphire system. The printed titanium parts are used for engine hardware, the environmental control system, and structural components. Characteristics of the geometric designs include tall, thin walls with high aspect ratios, which are inherently difficult to manufacture with either traditional processes such as welding and casting, or even most existing 3D printing technologies. VELO3D's unique support-free printing process enables unprecedented design freedom and quality control, eliminating manufacturing constraints to innovation in aircraft design. VELO3D's worked closely with both Boom Supersonic design engineers and Duncan Machine Products, the supply chain partner that handled both printing and post-processing that led 3D printing and machining of all the parts for Boom. PISA S9100, ISO 9001, and ETA certified. Boom Supersonic team chose the company's next-generation laser powder bed fusion technology to produce a number of printed titanium components located in critical areas of the plane. These included manifolds for the variable bypass valve system that routes air released by the engine compressor to the aircraft's outer mold line, exit louvers for the environmental control system that cools the cockpit and systems bay, louvers that direct the center inlet's secondary bleed flow to the OML, and NACA ducts and 2 diverter flange parts. NACA ducts are frequently used in high-speed aircraft to capture exterior air and channel it into the aircraft to cool the engine bays. All parts were printed on the VELO3D Sapphire system. XB-1 is the world's first independently developed supersonic jet. Boom's Overture airliner will include a carbon composite airframe, and is exploring the use of quiet and efficient Rolls-Royce jet engines that don't use afterburners during supersonic cruise. Boom Supersonic's XB-1, the 1/3 scale demonstrator for Overture, rolled out in October of this year, with flight testing slated to begin in 2021. The full-sized Overture will debut in 2025, and passenger flights are due to commence before the end of the decade. Hundreds of potential routes have been identified, and 2 major airlines, Virgin Group and Japan Airlines, have already pre-ordered 30 airliners.